Hello everyone. We're going to talk about a few special topics about classes and objects. So one that's really useful is we often might have a project with many different classes. And so it becomes a very useful practice to then make every file have just one class. And other languages like Java, for example, actually would require this, whereas in Python it could be optional to code as we've been doing. The idea is that what we end up having is we have one file with our main, we sometimes call it the driver. This is where the code lives. And then we're going to have separate files for every class that we create. It's a way of organizing code and making things easier to reference. So how this would look is we would have a file called vehicle.py. You would write the code just as we did before in class. You'd have your class declaration, your attributes, your methods, same thing as before. But what you wouldn't have is you wouldn't have main. You would simply have the class. So there's going to be no main here. Okay? Just the class. You would then have what we would call the driver. Now, there's not an established name for this. This could be main.py, could be program.py, driver.py. Different languages have different ways that they would name this. But this is going to be where main lives. And so you're going to put main in here, just as you would before. Main is going to have the logic, the driver of your program, going to set everything up. If you have freestanding functions, they might go in here. If you have a global variable or something like that, an import statement, that could all go in here as well. In main, you're going to create your vehicle objects. Now, in order to do that, in order to be able to create a vehicle object, you have to tell Python where the vehicle object lives. Just like if we want to import something, we need to say, first I'd like to import random before I can use random.choice. And so the way we do that, the syntax for that is we say, from my file name, import the class name. Now, this is, file name is exactly the name of the class, exactly the name of the file, rather, minus the .py. So in our case, we would say, from vehicle, import vehicle. Now, in this case, they both have the same name, which might be a little bit confusing, but what we're saying is this vehicle on the left comes from the file name. So we're importing from vehicle.py, so we say from vehicle. Now, the one on the right, we're saying import this class name. In this case, it happens to be vehicle. Now, one other thing we wanted to talk about is what a class variable is. So in order to explain a class variable, I want to revisit what we've talked about for a while now, which are instance variables. So in this case, we've talked about multiple times. We have this instance variables. We have a make, we have a model, and we have an MPG. And when you mentally think about this picture, I like to think of it like this. Over here on the left, you kind of have the class. The class is the structure or the template. And then from the class, you create an object, or you instantiate an object, an instance. And so here we have a unique car1, and we have a unique car2. Now, they each get a copy, or a container, if you will, that's going to store the attributes, make, model, and MPG. But then when they're instantiated, everybody gets their own copy. So here we have Ford Fiesta. Here we have Scion XB. So they're very different. So they're all going to have a container called make, but what gets stored in there is unique. Just like everyone in a room might have a different eye color or a different hair color, something like that. So that's good, and that's what we use a lot of the times. However, it's useful sometimes is what if we actually want something to share data, right? What if we want to be able to count how many objects have been created in a class? Or we want a constant that can be shared by everybody. And so in order to do that, we're going to distinguish an instance attribute from a class attribute, or a class variable, as they're called in Python. These are attributes that are shared by all the instances of the class. Everybody gets that copy. This means that everyone can access that attribute. And what's also kind of unique about it is only one copy exists. These are sometimes called static variables in other programming languages. So let's look at what that actually would look like. Okay, So we're building our class vehicle. Now, we say num vehicles equals 0. So notice what happened. This is outside of the init, outside of the constructor. The constructor is not there. And there's no self dot. So that's the two first distinctions to note. No self dot, and we're not inside the constructor. Now, when you want to then, let's say you want to change the number of vehicles that have been created, what you would say is vehicle dot num vehicles. So it's an interesting example where what you're basically doing is you're using the name of the class and then the variable name. So the name of the class becomes the way that we reference the actual object, that's the class variable that we have. You could almost think of this like when you import random and you want to then use random.randRange, you would say random.randRange. Similar idea. So what you want to mentally picture about this is before we had these 1, 2, 3 instance attributes. And everybody got a unique copy of them, right? These are separate and unique. So if you have 100 vehicles that you instantiate, you will get 100 different make attributes or 100 different model attributes, for example. But we only have one num vehicles. That's it. So they are shared by everybody. So this is a way of making a variable or a constant, depending on what you're doing, that is accessible by all the objects and it's shared. So let's look at an example. Let's say that I first say, okay, I have not made any vehicles, but I would like to see how many there are. So I could say total is vehicle.num vehicles. Now, it's going to say 0 because why? Well, if we look back here, when you first make the vehicle class, when you define the class before you've created any objects, you set it to be 0. So now, you're going to say that there are 0 objects. Now, when you create your first vehicle, again, jumping back for a moment, we can see that every time we instantiate, we increase the number of vehicles by 1. And so this variable, again, is stored here globally, essentially, if you want to think about it that way. And now the vehicles is 1. So every time you call init, and when do you call init? Well, we call init every time we instantiate a new vehicle object. And so every time you instantiate a new vehicle object, you are increasing this variable, num vehicles. Just like that. So one way to help understand class variables is to maybe connect them back to what we've already learned, which would be global variables. And so how could that be different? So let's just look for a quick example at comparing global and class variables. So if we have a student class and we have max courses, so students can enroll in 6 courses at once, at most. So we would build our class, we have our attributes here, we've got a list of courses they can enroll, you can add the course. Now if you want to add a course, you could say max courses, because this is a global variable, it's defined up here, we can access it whenever we want. Okay? That's fine. Now, what would it look like to make this a class variable instead? What we would do is we would define max courses inside of the student class. And so now, going back to where we were, when you want to add a course, you check if student.maxCourses, as long as we're less than that. Now, there might be a question of what's the point? Why would we want to do this way instead of the other way? Well, one thing that's kind of nice in object-oriented programming is if you think about, let's say you're building a university system. Well, there's a lot of max courses. A student might have a max courses. A classroom might have a max number of courses that can be enrolled in that every day, let's say before it needs to be cleaned or whatever. A faculty member might have a max number of courses that they can teach in a semester, and those numbers might be different. Maybe faculty members teach, I don't know, 4 courses or whatever it might be, and students take 4 or 5, whatever the number would be. So it's kind of convenient to move this global variable, which is accessible to everybody, and just putting it inside of the class where it's most relevant. And so that's why one of the reasons that we would use a class variable instead. Effectively, the code could be the same, it's true, but it's nicer to put it closer to where it's going to be used, which is a class. So I just wanted to conclude by summarizing quickly what we've all talked about with all these variables, because it's going to be a little bit confusing. So a local variable, right? This is when you define it within a function or a method. It exists only inside the function, and it's typically used for temporary operations. So when the function ends, remembering how scope works, when the function ends, that variable goes away, disappears. Okay? A global variable, or in this case a global constant, is declared outside of any function. They exist everywhere in that file. They're useful for constants. You can use them for variables as well, and they can be accessible anywhere. Then getting into the idea of objects and classes, last time we talked about this idea of instance attributes or instance variables. These are declared in a class. They do exist as long as the object exists. They're always defined with self dot, and every instance gets a unique copy of these. And lastly, we just introduced the idea of a class attribute or a class variable, or sometimes called a static variable. And that is also declared in a class. It also exists as long as the programmer is running, but the major distinction is that there's only one copy of those, so they are shared. That's the major difference.